Hello guys, this is Sushant. So we meet again with our second session in indefinite integration. I'll be trying to cover up most of the types of sum in this particular video. Please like the video, share it with your friends, and if you are new to this channel, please subscribe to us so that you get regular updates on the videos which we are doing for our MHTCET mathematics. So let's get going for our indefinite integration. So we have 1 upon x plus x raised to minus 3 dx. We have to find the integration of this. One of the very rudimentary way to solve the indefinite integration is to find the derivative of each and every option and see whether it is coming as this particular function. But I won't advise that, because if your option is basically your option D, then in that case you have to find derivative of A, B and C also along with it. So that means that you have to waste your time solving 4 problems in that particular case. So I would not advise you to go by that method. It is only advisable to go by that method if you are able to solve your derivatives in a very quick manner. Now, whenever you are solving any sum in your indefinite integration or in any integration, you have to know first thing, that is, it should stick to some of the formulas which is in the list of formulas for integration. If it is not fitting in any of those formulas, then it is considered as a bit complicated type of integration. So when the type of integration is bit complicated, the first way in which you have to solve is by method of substitution. The method of substitution should be given the highest priority whenever you are solving that particular integration. After that, you will be having the other forms of integration, that is by solving it by partial fraction method or solving it by finding the quadratic equation, forming the perfect squares of it, and the last option should be given to your finding it by integration by parts. That should be your last option, because the integration by part itself, the formula is a bit complicated in nature. So whenever you are seeing some problem like this, the first method which you have to go is your substitution method. Now, for substitution method, the thumb rule basically is you have to have a derivative of whatever substitution which you are going to do. Now, that derivative should be with your dx term. So sometimes it is quite easy to understand what should be the substitution, because along with the dx itself you are having the derivative term, so you are able to find the substitution. But in sums like this, it's not quite possible, because you can see that along dx there is nothing present, it is just 1. So you don't know exactly what is going to be the substitution in this case. So let us try to simplify this particular problem a bit. You know that it is x raised to minus 3, which can be written as 1 upon x cube. You will be having a x cube into x plus 1 divided by x cube, and that x cube goes in the numerator with the dx. So this becomes basically x raised to 4 plus 1. So now you can get a clear idea that along with dx you are having the x cube. So the function, if you are substituting x raised to 4, its derivative you should know that it is 4x cube. Now 4 is some constant which you can just multiply and divide. So you can just multiply your 4. So what you are having is your function is this, and the derivative part is over, and the derivative part is present in the numerator. So when you are taking integration of this, so it is of the form derivative of a function divided by the function. So whenever you are having anything of this sort, then the answer is basically log of the function. So in this case, it's going to be log of x raised to 4 plus 1. And since there is 1 by 4 which is present outside the integration, so that 1 by 4 will be present over here. So your answer is basically this. So that's your D option. Going to the next one, you can again see that you are having e raised to 2x plus 1 upon e raised to 2x minus 1, which is quite complicated. It is neither e raised to ax form or any of those sort. So you have to go by substitution method. So now substitution method, you cannot find it directly, but you can just observe the option. There is no presence of e raised to 2x in the options. So that should give you a click, that should click in your mind that you have to basically somehow bring it into form of e raised to x. So what you can do is you can divide the numerator and the denominator by e raised to x. So you will be having e raised to x plus e raised to, that is going to be 1 by e raised to x, that is e raised to minus x, divided by e raised to x minus e raised to minus x. This is with your dx and you are finding the integration. Now if you just observe something over here, if you are doing the substitution of the denominator, which is e raised to x minus e raised to minus x, and you find the derivative of it, you will land up something which is present in the numerator. So again it comes in this format, that is you are having the derivative in the numerator and the function is present in the denominator. So your answer is going to be log of e raised to x minus e raised to minus x plus c. So if you just check out, it's going to be your option A. Don't get confused with the alphas and e's and c's over here. Alpha is nothing but a constant. So just to play with your mind, they have given that extra thing over there. Moving on to the next one. We have sec of root x divided by root x dx. Now you will be knowing the formula for sec x, but this is basically a sec of root x and divided by root x. So it is not in any of those integration formulas which you know. This you have to do by substitution method. Now substitution method, what should be the substitution, you will be wondering. So you can see that you have along with dx, you have either a sec root x or a 1 by root x. Now obviously you cannot have something which is sec root x with the dx, because you will not be able to find what is a function. There won't be any function which will give you the derivative as sec of root x. But if you have dx along with the root x, then if you just substitute root x as t, you know that derivative of root x is nothing but 1 upon 2 root x dx is equal to dt. So you are getting this particular as the derivative. So you require the 2, so you will be multiplying the 2. So this has been brought down to this particular form, that is 2 of integral sec t dt. Now when you are finding the integration, you will be having the answer as 2 of log of sec t plus tan t. But if you just mark your option as B, which is given, then it should be your wrong answer, because your t is not the variable which you are interested with. You are interested with finding what is going to be with respect to x. So that is why you have to do your resubstitution, that is your t as root x. So that will lead you to the option C. So when you are solving this particular sum, this itself that you are having a t inside it should trigger in your mind that that option might be a wrong option. So you should hesitate in marking that particular option. Moving on to the next set of questions. In the first one, we have a sin x minus a upon sin of x plus a dx. Now, in this sort of questions, whenever you are having a sine upon cos of some bracket which is x plus a, x plus b or something sort of like that, what you have to try to do is, you have to try to bring this particular, that is x plus a along with the sine in the numerator. So what you can have is a sine of, you require the x which is present over here, but you require a plus a. So if you are adding a plus a, so you require a subtraction by a minus 2a. So you require a subtraction of 2a. So this thing divided by sine of x plus a. If you find integration of this, what you will be able to see is that this is my A and this is my B, so it is sine A minus B. So sine of A minus B leads to the formula, that is sine of x plus A into cos 2A minus cos of x plus A into sine 2A. This thing is divided by sine x plus A. So when it is divided and when it is split up, you will be getting only a cos by 2A and this becomes a cot. So you are finding integration of this, wherein you can just see over here cos 2A is a constant term. So it will come outside the integral. So it is just integration of dx over there. So that comes out to be x into cos 2A minus, in this sin 2A is constant and integration of cot is to be found out. So it will be sin 2A into log of sine of x plus A. So if you just check out the option, it's going to be your option D. Be very careful while selecting options like these sorts, where you are having the terms almost placed at the same position with a difference of a minus and a plus. Moving on to the next one, we have 1 upon x square minus 2x sine alpha plus 1, which is actually given to us that it is sec alpha into tan inverse of mx plus c. So in this case, you can just find the derivative of this term and then compare it with that particular thing. So if I find derivative of this, so it's going to be sec alpha into tan inverse derivative, which is 1 plus mx plus c the whole square into m. You are going to have the terms as m square x square plus 2mcx plus c square plus 1. If you just compare this two equations, what you see that in the numerator you require a 1. So what you can do simply is you can divide the numerator and the denominator by m sec alpha. So once that division is done, then you can do the comparison of the coefficients. So this becomes m upon sec alpha, which has to be equated to 1. So you are getting the m value as sec alpha. Then comparison of this two, so 2mc divided by m sec alpha, where m gets cancelled out, you are getting it as it should have the value 2 sine alpha. So the 2 gets cancelled out and your c should have the value which is going to be sec sine alpha into sec alpha, which is nothing but 1 by cos alpha, and your c will be a tan alpha. Just to make sure that you are getting it right, you can go for the third term. So that's going to be c square plus 1 upon m sec alpha. That should be compared to your 1. Your c, you are getting it as tan square alpha. So that's a tan square alpha plus 1 divided by m, you are getting it as sec alpha. From here you will be getting your m as sec alpha. So sec alpha into sec alpha, which gives you a sec square alpha, and tan square alpha plus 1 is sec square alpha. So whatever you have got is basically right. So that is why your option should be where you have m is sec alpha and c is tan alpha. So that option is pretty much available in your option B. Moving to the next question, we are having this as 1 upon root of 4x square minus 4x plus 3 dx. Now if you just go and find the derivative of these options, then again it becomes an impossible task. So we have to try to decode what is going to be the answer for this. So what we can do is we can take the 4 outside. Since it is coming outside the root, it's going to come out as 1 by 2. And inside the integration, it's going to be root of x square minus x plus 3 by 4. Now what you have to do is you have to make this as perfect square. So while making the perfect square, what you have to keep in mind is you have to see the coefficient of x. It's in this case it is 1. So it's going to be plus 1 by 2 square. Since you are adding a 1 by 2, you have to subtract a 1 by 2. So that is subtraction of 1 by 4, and there was a presence of 3 by 4. So this becomes a formula for 1 upon x minus 1 by 2 the whole square minus this one is 1 by 4 plus 3 by 4, which is 2 by 4, which is basically 1 by 2. If you are writing this as, which we can write it as 1 by root 2. So this integration is in the form of 1 upon root of x square minus a square, which according to the formula is 1 upon 2 log of x minus a, that is basically x term plus root of x square minus a square. So since it is x square minus a square, it's going to remain in this format only, plus c. So if you just check out for this option, it's going to be your option B. Moving to the next set of questions. The first question is, you have to find integration of sine divided by 9 minus x sine square x. Now along with the dx, you can see that there is a sine present. So for the derivative to be a sine, you require the substitution to be a cos. So you can see that it is 9 minus sine square, which you can convert to a cos square using the trigonometric identity sine square x plus cos square x equals 1. So you can substitute your sine square x as 1 minus cos square x, which makes it a plus cos square x. So this 9 minus 1 becomes 8. Now what you can do is you can just substitute the value, that is you can substitute your cos x as, so you can substitute your cos x as t. So when you are taking derivative of it, it's going to be minus sin x dx equals dt. So that minus will go along with dt. So now your integration is changed to a minus dt divided by root of 8 plus t square, which you can write this as 2 root t the whole square plus t square. So this is of the form 1 upon root of a square plus x square, which we have already seen the formula as log of, it's going to be x, which is in this case it's a t, plus root of whatever is present inside it. So it's going to be 8 plus t square. So now we have to do the substitution, that is a resubstitution. So my t is basically cos x, so it's going to be log of cos x plus root of 8 plus cos square x. Now in this what you can see is that it is the option is not present currently. What you can do is you can just change this to your sign again. You can change just the option to your sign again, because it is just going to be cos square is equal to 1 minus sine square. So that's going to be a plus root of 9 minus sine square. And your cos, you can write your cos x as root of 1 minus sine square x. So if you just check this option, it's going to be your option D. Moving on to the next one, you are having e raised to x into 1 minus sin x divided by 1 minus cos x. Now whenever you are having the e raised to x, you have to try to bring it in the form of e raised to x into f of x plus f dash of x if it is possible. Otherwise don't try to do it. That is, you have to bring it in the form of e raised to x into f of x plus f dash of x. This is just a tip whenever you are having e raised to x into a complicated function. So because you know that this formula will nothing but e raised to x into f of x. So what you have to do is you have to bring addition of a function and its derivative. To do that, we have to first of all simplify this particular function. Now to bring this particular function in this format, what you can do is you can write your sin x in the half angle formula and your 1 minus cos x also in your half angle formula. So we'll be having a 1 minus 2 sin x by 2 into cos x by 2 divided by your 1 minus cos x will be nothing but 2 sin square x by 2. So when you split this up, you will be having something which is 1 by 2 into a 1 by sin square, which is nothing but cosec square x by 2 minus this 2 and 2 gets cancelled, one of the sin gets cancelled, and you are having a cos upon sin, which is nothing but cot x by 2. So now you have to decide which is the function and which is the derivative. So in this case, clearly if I just substitute cot x as f of x, then its derivative is going to be minus cosec square x by 2 into 1 by 2. So what you can do is you can take the minus sign outside, so this becomes a plus and this becomes a minus, so you are having minus e raised to x and this integration. So you are having now your e raised to x, and this is your f of x and this is your f dash of x. So your answer is basically minus e raised to x into cot x by 2. So if you just check out this particular option, it comes in option C. Moving on to the last one, you are having 2x upon 1 plus cos 2x. Now whenever you are having this sort of question wherein you are having an algebraic term and a trigonometric term, and the angle which is present in the trigonometric term, the derivative of that angle is not present along with the dx, then only in that case most of the time it is of the type integration by parts. So in this case you can see that 2x is the angle and its derivative is obviously not going to be a 2x dx. So this becomes sort of like the integration by parts, but you won't be clearly able to solve it directly. What you have to do is you have to first of all simplify this 1 plus cos 2x using your cos 2x formulas. So the formula which you will be, so you know that 1 plus cos 2x is nothing but 2 cos square x. So your 2 gets cancelled, and this you can write it as sec square x into x, integration of this. Whenever you are solving the question by integration by parts, what you either you remember the formula which is given to you, or you can use a simple sort of a table in which your table will be consisting of two columns. The first column will be consisting of the derivative function, and the second column will be consisting of the integration function. So once you have decided which is going to be your integration function and which is going to be your derivative function, then you can go for this table. So I have decided my derivative function should be x. So my derivative function should be that function which along as I take the derivative of it is going to become 0. So in this case, if I take derivative of x, it's going to be first derivative will be 1 and the second derivative will be 0. So it is getting rid of. So that is why I will be choosing x as the derivative function. The obvious other part should be the integration function. So in this case, my x is the derivative function and the integration function is sec square x. So now what I have to do is I have to find the derivative, continuous derivative of this part and continuous integration of these parts. So my x derivative is 1 and its second derivative is 0. So I will end it over there itself. Next I have to do sec squares integration, which is going to be your tan x, and tan x integration, which is going to be your log of sec x. So you will end this also where you are finding that your derivative is becoming 0. Now what you have to do is you have to draw these arrows. So your arrows will start from the first element of your derivative to the second element of your integration, the second element to the third element to the fourth element, and so on. Once the arrows are drawn, what you will be doing is giving the signs. So this positive sign indicates that the product of this is going to be positive. So your answer is going to be basically x into tan x with a positive sign. Second is going to be 1 into log x with a negative sign. So minus log of sec x plus c. So this is going to be your option. So if you just check it out, it's going to be your option B. So I hope you have understood this particular table, which becomes very much helpful when you're calculating your integration by parts. So that's all for today. We are wrapping up with our indefinite integration. We'll be taking up a new topic tomorrow, which will be related to your mathematics. So till then, please take care, keep learning, keep practicing, keep watching, and happy learning. Take care. Bye.